Hey, friends. You having fun? All right. Are you having fun?
I'm having fun.
All right. I want to make sure that we set our expectations for this talk as low as Mark's expectations for this talk, right?
They're really low.
They're extremely low. Because not every talk has to sell you something. Not every talk has to be, what was the word you used? Educational?
Yeah.
Right. This talk is none of those things.
Nope.
Right. You will learn nothing from this talk.
Yeah. So if you're coming here like, I'm going to learn something.
You're not.
You're not.
Just make sure that when you're filling out the form, you do the little QR code at the end, and they say, did I learn something in this talk?
Just say yes.
Just say yes.
Yeah.
Okay. What we're trying to do is connect the dots. Mark and I have been around for a minute, and we have been enjoyed computer science over the last many years, some decades, right? You've been 29 as long as I've known you. But we want to kind of connect a bunch of stuff and make some delightfully fun, silly demos
gratuitous
that make us happy. Gratuitous? Is that what we're going with today?
Yeah.
I said delightful, he said gratuitous. They're going to be obnoxious and they're going to be silly, and they're very likely not going to work. So again, low expectations. If you feel you can't give us a good review, you should just leave. You should just leave. You should just leave. Okay, so the year is 1975.
Big year.
It was a big year. I was of a certain age, and you were probably getting your PhD.
No.
Wow. We brought an Altair Mini right here. This is an Altair from 1975. That's the machine that Bill Gates wrote BASIC on, right?
1975 is the year that Microsoft was founded.
Yep, micro-soft.
Yep.
Micro-soft was founded then. And this is a time when we were really one with the machine. It was a time when you could understand the machine fully all the way down. This machine right here.
Make your own from parts, PCB boards. And
exactly, and this is an emulator, a Mini. It's called an Altair Mini. It's a little smaller.
Yeah.
I built that from a kit, so I soldered that. So I understand that thing 90%. But all the wires, everything in there, I understand. And that's a time when you're really driving stick shift. And it's worth noting that. Now, Azure, do you understand Azure completely from top to bottom?
Yep.
Right. So that didn't work.
Yeah.
That didn't work. But with the Altair like this machine was a microcomputer that would have basically one user on it. It's not a mainframe. There were multitasking operating systems for it, but as a general rule, this was a one-person, one-program kind of a machine. And there was a thing called a bootloader on this here, and you would actually flip the bootloader like this. Oh, look at that, that's Mark. Hey, Mark.
Yeah.
We have a podcast, so I would encourage you to check it out. Thank you, woo! The one guy who listens to the podcast. Oops, sorry, boss. So you would key in the bootloader. It was like 28 bytes or 26 bytes, and you would go and flip, 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 load, flip, 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 and you'd set all of these switches, and then you'd load in the bootloader, and then that would say where I want on disk or in memory to kind of jump to, and it was very, very low level. It would take a while to boot the machine up. Does Azure have a bootloader?
We do.
Is it like, do you just flip switches? Do you have to go and fly there?
So there's, levels of abstraction, as we'll see. So at the basic level, it's booting a server, which has a bootloader.
So each individual server in Azure has a bootloader.
Bootloader, yeah.
And is it like it's the bootloader on my Surface?
It is. It's UEFI. And in fact, Project 𝗦𝗲𝘀𝗀𝗃, which is open sourcing UEFI and having it rewritten to Rust, is the same thing that we'll be running on Surface books.
And whether or not this is useful information or whether this is going to help you go back and implement Microsoft Fabric back at the office, again, it's not. But it's interesting. It's interesting that whether it be a 28-byte manually set up bootloader in 1975 that boots up an Altair into CP/M, an operating system, or whether it boots into Microsoft 4K Basic, written by Bill and Paul, or it's a Surface or Azure, bootloaders are a thing, and they have been for over 50 years. Yeah. And it's a well-understood science.
Yep.
Yeah. So this particular machine here right now isn't doing anything, but we do have some assembly code that I've set up to set up these lights moving back and forth. That's actually a program written in assembler. And this one is playing Pong. Now it's playing Pong badly because it's only going that way and no one is flipping on the other side. Okay?
Oh, is that my cue?
Yeah, that's your cue. Let's see if we can do that.
Wait.
So you're going to be switch 8.
Okay.
No, you got it. No, 8. No, is it 8?
Yeah.
This one.
8.
8.
7.
No, that's 7. This is 8.
I did 8.
No, that's 6.
Oh, 8.
No, you got to hit it when it hits you. You got to bounce
There's
it back.
a timing thing.
Bro, boom.
There.
So you can see that there's a clear skill issue there. And I recently was blessed to go and visit the Interim Computer Museum, which is an extension now. They've taken a lot of the things from the Living Computer Museum, and in 𝗬𝗀𝗀 and Tacoma there by the airport, there's the Interim Computer Museum. You can check them out at icm.museum, and they have living machines like this that you can actually touch, and you can actually play with. And the kinds of code that you would write is like this. This is like, I want to move this bit into this register. I want to set this output. Do people on Azure write code like that? Are there assembler people at Microsoft?
I mean, there are some, yeah, actually. There's some pieces, yeah, but not very many.
Not very many.
No.
It's all Rust.
That's right.
You love Rust.
Well, yeah, I love Rust.
Okay, and why do we not do this anymore? Why would we avoid that?
Levels of abstraction.
Levels of abstraction.
Compilers.
Okay, so you don't want to spend your time here because you're on the metal. It's very, very challenging. You could hurt yourself and potentially break a machine.
And it's worth noting, too, that before there was assembler, there was just machine language. It was like going decoding the bits into bytes.
What is the difference between assembler and a machine language?
Machine language is just the raw bits that form an instruction. Now, assembler is a kind of textual representation of those bits, like the move instruction. Underneath, that's a byte that has some bits set in it that the processor interprets. But it's much easier to type move than the hex number for the move instruction.
Even assembler itself is still a layer of abstraction that's still quite a few steps away from
above from the machine. Yeah.
Could you read machine language as a 𝗦𝗲𝗀𝗀𝗀𝗀?
Yeah.
That's kind of a flex. That's kind of awesome. That's kind of awesome. So you saw me go and load up the Altair 8800. Again, this is an Altair Mini. You can get these on a kit and build them. This is an actual Altair. The Altair is about that big, so this is about half size. But it is a true simulator, and it is darn near clock perfect. But in the case of the Pong application, I was using assembler. But a lot of us of a certain age grew up doing things with BASIC.
Yeah, how many people had their first language as BASIC?
Where are BASIC people at?
Yeah.
Excellent, excellent. Any people in their 20s but also learned BASIC first? No? Couple
there's
BASIC
one.
people.
Yeah.
We appreciate you.
Yeah.
Things like Python is the new BASIC for a lot of people.
Yeah.
Things like Scratch, MIT Scratch, Microsoft MakeCode. It's just a very friendly, convenient layer of abstraction. And you were writing BASIC and talking about it actually online. You do things like Hello World.
I know how to do that.
And
by the way, there's a bug.
There's a bug there. I was going to say, I was looking at this, I'm like, how did we not notice
that? Because you write.
Did I write that?
Yeah.
I went and I shipped a bug live on stage, and it's in BASIC. Right at review time. What am I doing? Oh, what a nightmare. So many machines have run BASIC. I ran a Commodore 64. What was your first computer?
Apple II. No, yeah, Apple II.
Apple
actually.
II?
Yeah, friend's dad brought one home from the university. I was in eighth grade. Mm-hmm. He's like, hey, let's go check out what my dad brought home, a personal computer. And we started playing that night, stayed up till like 5 in the morning. I said, this is my career.
You said, this is my career?
Yeah, I did.
You're like 5 years old, and you're like, this is it.
4.
4 years old. Now, when I saw games like this, I thought this was unbelievable. Like, we would have graph paper, we would build,
Look how realistic that image is.
Oh, yeah.
It's like...
This kind of stuff captured our imaginations, and I've been thinking to myself, what is the thing that's going to capture the imagination of someone in 2025? When someone looks at, like I've seen kids wandering around the streets going, well, man, the resolution is so high out here, and they're outside. It's like 4K, it's ray tracing, everything's ray traced. I thought that this was absolute
It's like photorealistic.
Absolutely photorealistic. Now, this is a really exciting thing here. We've got a Compute magazine. Let me zoom in on this.
Yeah.
This is a real thing that Mark found.
Anybody read Compute back in the day? Yeah, okay, a few. 1, 2. So this is my first published article. This is from 1985. I wrote the article when I was 16. And it's because I had the Apple II, actually ended up buying one from the school library that they were selling, and then got an Epson dot matrix printer, and I was like, I can get the screen printed and hang up cool images around my bedroom, which was completely plastered with these things. And that's the program that I published, Apple II high-res screen dump.
Yeah, I was trying to zoom in on that, but I'm not able to. For some reason, my mouse has disappeared here. This is December 1985.
I thought you had the next slide.
No, I know. I wanted to zoom in on the actual. It was $2.95 for that.
There.
And now I see BASIC on the right.
Yeah.
This is a little more complicated than Hello World.
Well, so what you would do with these magazines, because there was you couldn't ship a floppy or a CD on them, you would print out the hex codes. This is the machine language codes, basically, and type that in and run it, and then that would load that into the computer. And so if you did this, you would load the screen dump program, and then on the right side is BASIC that actually shows you how to dump the screen using that code.
So you could at the time read that stuff on the left there.
Yeah.
And I see load.
Yeah, that's the binary load.
Binary load. Address 2000.
Yep.
All right, let's switch over to the main machine here, and let's see if I can run. Oh, sorry, go ahead.
Yeah, well then, the next program I wrote.
Oh, the next program you wrote.
Yeah, I wrote another one.
You've written more than one program?
This one is, yeah, another one. I actually got into the internals of the AppleSoft and BASIC that Bill Gates wrote, and had a disassembler of it, and figured out how I could make it better. Back then, you could only go to constants, like go to 10 or go to 20, and I wanted to make it so you could go to some variable or some expression. And so I wrote this program to extend AppleSoft and give you that ability and then publish that as well. And this was really cool because they made my article the cover theme for the issue, because that's the better branching thing. And a while ago, I was like, I bet Bill Gates would find this interesting, that I made his BASIC better. And so I sent him an email and said, hey, Bill, I did this back and, extended AppleSoft to your AppleSoft, and I made it even better. And he's never answered me. So I don't know if he's impressed by that or not.
Now, when you met him later,
yeah,
as an adult, and when you mentioned it, was he also unimpressed?
Yeah. He did.
So let's see if we can switch over here, and let's try this real quick. This is the Altair, and I have found this to be a bit persnickety a couple of times, so bear with me for a second. What I've done is I've plugged the Altair into Windows Terminal, and I've got it plugged in as a COM port on COM3, and I'm using a tool called Plink, which comes with PuTTY, and I want to hit stop up and aux1 up. There we go.
There you go.
And I'm getting into a menu, and I'm going to say D, and I'm going to mount a couple of disks. One is going to be CPM, which is an operating system. And then I'll do this one here called game. So I'm going to have an A drive and a B drive. And then I need to set a disk boot ROM. So let's switch back over to the camera here, because I have to put in a bit mask that describes where to jump. 1, 2, 3, 4. There. Okay. Switch back. Ooh, it worked.
You did it. Wow.
Holy crap. It's never worked. It's never worked on the first try. Whew. Okay, cool. So this is CPM, which is an operating system. This could run multiple operating systems. So can you navigate here our A drive? What's on the A drive? Ooh, MBasic. That looks promising. I'm imagining a disk sound like. Oh, you're going to code live on stage in BASIC?
Yep.
By Microsoft. Very nice. This is good. Uh-oh. Hey, are you trying to crash this thing?
Whoop.
And there it is.
It's my first program again.
Oh, I would call that your first bug, because that thing's spinning forever.
It's gone.
Do you know how to stop it?
No.
Oh, okay. All right. Goodbye, everybody. That's the end of that's the end of that talk. So in this case here, I don't actually know how to stop it either. And this is an encoding thing, because if I hit Control-C, I've exited Windows Terminal, but the app is still running in the background. So I will deal with that later. Thank you for that. Thank you for that gift.
Sorry about that.
Thank you for that gift. This is the 4K bootloader. I think this is the one that, that legendarily Paul Allen wrote on the airplane, and they realized they didn't have a bootloader.
Oh, yeah, yeah, he had to do it.
They were
last minute.
flying to a demo, and he's like, oh, crap, I need a bootloader.
Yeah.
So he wrote that on an airplane, similar to the way Scott Guthrie wrote ASP.NET on an airplane.
Oh, crap, we don't have ASP.NET.
Yeah, exactly.
Yeah.
It's just like that. No internet, just completely hardcore. But then we got connected, right? It turns out that being connected is better than not being connected. And we would have these terminals like this. You've got a terminal on the left. The computer is not on the left. The computer is actually the refrigerator on the right. And then you would go and you talk to, no, hang on a second. There we go. You go and you talk to the machine, but the rendering is happening on the terminal using something like VT52 or VT100.
VT100, that was the game.
VT100 gang. But the work is happening on the giant fridge over there. And that connectivity was a moment for all of us. Now, this right here was very expensive. Very expensive.
State of the art. 56K. I mean, yeah. To get better than that, you needed to go DSL. So,
yeah. Now, AV friends, I can't see my mouse. I'm wondering if you could either click on that button for me or help me see my mouse. There's my mouse.
Yeah.
We just wanted to dial into Azure real quick.
Connection list sounds good.
That's it?
Yeah, I can see.
Yeah, that's a good one. That's high.
Yeah.
That's good. I thought that was going to be 28.8, but nope.
What's
That's
that?
not good. Is it going to pull it off at the? Yep, it's good.
Right, good.
All right, great. About 38.4 right there. That was good.
Yeah.
You could tell.
You could tell, yeah.
You could tell that
It's
was not a
connecting,
good one.
yeah.
And you're like, Mom, hang up the phone, Mom. I'm online. And I ran a bulletin board in my garage on OS2. I had multi-lines, and I had business cards I would hand out around the neighborhood that said only dial after 3 p.m. That's when I got home from school. And this is a bulletin board called 𝗦𝗽𝗲𝗸𝗶cie, and then I went to Microsoft and went to work for a gentleman named Scott Hunter, who
I just saw.
wrote Wildcat.
He's here.
He worked at Mustang Software,
That's
so
crazy.
I did not realize that when I was 15 in my garage on Wildcat,
Your boss
I would end up having my reviews, annual reviews being done
by the guy that wrote
by the guy that wrote Wildcat. Yeah, isn't that crazy? And we would connect to things and play games. We would play these multi-user dungeons, MUDs. We would play things like Zork. If I remember correctly, I might be able to, let me see, where we are in our demos here. I got turned around, brother. Yeah, let's go back to this. I think I want to connect and try to play a game on this. So let's switch back over to here. That guy is doing its own thing. So let's go back here. Okay, you've crashed it.
Yeah.
So I'm going to plug it in and unplug it and plug it back in again. So thank you for that. And I'm going to go back here. Yep. And I'm going to go like this because I need to speed up. And I remember it was stop and that. Okay. And I'm going to come back here and I'm going to go disks. Boop. Boop, 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 boop.
Games.
Boop.
Yep, nice.
Boop. Bootloader. Boop. Boop, 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 boop. Boop, boop. Games.
And where is it?
I don't see the game I want. See Star Trek, though.
Yeah.
Stop run. Ooh, that's a game. This is important stuff, people. Hey! There we go.
Lots of Zorks.
Yeah, all the Zorks. Zork 1, 2, and 3. Yes!
Yeah, Zork.
Sweet.
Anybody play Zork? Yeah?
Can you see the graphics in your brain? Open.
Super high res.
Mailbox.
Yeah.
Open leaflet. Welcome to Ignite.
Why didn't you just take the leaflet? Why'd you open it? Oh. Like that?
Yeah. Yeah. Sorry,
That's the intelligent thing to do,
I wasn't able
by
to
the
pull
way.
that out of the archives there, bro. Bruh. There you go.
There,
I was
all right.
losing all my nerd cred. All right. So let's switch away because you told me we need to speed up. This is good. Okay. So fast forward to the internet, and we start open sourcing everything. We start plugging things together. We start sharing code, sharing experiences online. Look at that beautiful man.
Is that you?
Dude,
wow.
That's me with your hair. Now you know what would happen if we had a baby. So I went and I built the first portable blood sugar management system on a Palm Pilot, and I did that in 4K.
Yeah.
And it got written up in the newspaper.
That's pretty awesome.
That's pretty awesome, yeah. And that's my first website, which is pretty sweet. Nice. And,
yeah, and I started a website and a software company, Internals and Windturnals.
Shout out to the construction GIF in the corner there.
I not only learned BASIC, I learned HTML, as you can see.
Yeah.
Professional
Pretty
HTML
nice.
programmer.
Tables. Tables will get you a senior engineer job just like that if you know tables. And what do we got here?
So this is the original list of now Sysinternals utilities.
This is Sysinternals?
Yeah, and there's only one of them that still exists today on this list, and that is WinObj. WinObj exists, yeah, almost 30 years later.
So WinObj looks like that in 1996.
Yeah,
and there's of course a bit of modern UI refresh.
Lots of work.
All of the latest.
There's the new one.
Bro.
Yeah.
What are you doing?
Well, guess what it's got?
Okay, let me see. Let me see if I still have WinObj on my.
I mean, you just laugh, but it's got themes.
You got themes. This is WinObj. Yeah. Nice. Refresh. Theme. Oh, theme.
Dark.
Ah.
Yeah.
Look at that.
Didn't have that in 1996.
Bringing us into the late 2000s. Good job, brother. That's amazing. And that thing still runs 30 years later.
Yeah.
That's fantastic. And then the Sysinternals newsletter, because before social media, you would email people.
Yeah, newsletters are back.
And it's coming back. Yeah. Everyone's coming back. And how many subscribers?
60,000.
60,000 subscribers in 2006 on the Sysinternals newsletter. Fantastic. So we saw me run Zork here, but Zork is a 50-year-old application. I thought it would be interesting to see if we could run it maybe somewhere else. Like Azure.
The cloud.
Like the cloud. So what I'm going to do is I'm going to switch back over here, and I'm going to go shell.azure.com, and I'm going to log into Azure real quick. We do need to hurry. So I will. And I'm going to go into Azure, except the Azure Cloud Shell is, interestingly, it's a container, and it doesn't allow me to have sudo. I'm not an administrator. I can't install stuff.
Yeah.
It's an ephemeral kind of a world.
Well, it's actually, you can make it persistent.
But it's not going to let me install stuff, right? It's not, it's a Cloud Shell. So under Cloud Drive here, I wrote this Zork Cloud Shell setup, which goes through and patches.
You're hacking.
I'm hacking Cloud Shell and hacking Zork because it doesn't have the term caps, the terminal capabilities that I needed. And what I'm going to do is clone Zork.
Oh, do you want to mention that all the code you see in this 100% vibe coded?
Well, that's a great point. We did not write any of this code.
Zero.
But we did give very explicit instructions.
We were really good at prompting.
So I'm taking full credit for doing this work. Okay? So now, Zork is a directory, which is exciting. There we go. So there's a freshly compiled Zork from a moment ago, now running on
in the cloud.
In the cloud, on the cloud. So that's running in a kind of a little bit of a containery kind of a thing, which may or may not be that impressive. But then I thought it would be cool to add more AI, because we are contractually obligated to do that. So what I did is I put that Zork in a Docker container, and then I made a driver that would talk to it and scrape the screen, and then I send it off to ChatGPT and GPT-4o-mini, I think?
I think, yeah.
Yeah, and then I stuck it in a Docker container, and I can spin up a Zork and then have the LLM play it, so then it'll take the leaflet.
Yeah, that's intelligence right there.
That's intelligence. So now I get no joy or fun out of the game at all. All right, so that's pretty cool, right? I'm running Zork locally, and I'm going to maximize my score with AI, and I'm running it here on Ubuntu, on WSL, on the Windows.
That's nice, but it'd be better if we actually did that in the cloud for real.
Okay, so let's make it better.
So let's make it better. So let's go, and we're going to go to This one?
Yep.
Yep.
So if you look into the lower left-hand corner of Visual Studio Code right there, he is shushed into the cloud. We're shushing in. Remember, we're trying to make that a thing. So I want you to just go back to work and just say, yeah, I'm going to go ahead and shush into production.
And you got rid of my command history, so and
I did not.
You did?
Nope. That's not my fault.
And okay, so
you can pull up that right there.
and
All right, cool.
Nope, this isn't. Yeah.
Is this it?
What the hell did you do?
So this is going well.
This. All right, I need to CD into scripts. I know.
You want to look at this script right here?
And then I need to do. Oh yeah, I might as well.
Yeah.
Activate.
Paper.
Yep. From.
We wrote it down.
Okay, so what we're going to do is actually. Let me pull open the browser. Is this it?
There's a lot of browsers here, bro.
God, you're just a mess.
This is a browser, maybe?
This is the one. This is the one,
browser?
actually, that I want.
Or that one?
Nope, this one.
Okay.
So this is a resource group here that I've got, which has got ACI standby pools. And what I'm going to do with running that Docker container with Zork in it, and what I'm going to do is launch a Zork AI arena.
Like a swarm.
A swarm. We're going to have AI compete with each other to solve Zork, because you get points as you play Zork.
Okay. This seems like a useful demo.
Yeah, and I'm going to launch 3 of them.
Feel the value.
I'm going to launch 3, and if we go back to the resource group.
Okay, Zork standby pool. Remember how we said you weren't going to learn anything?
Yeah.
You only learned that computers can be delightful and that you can spin up
and we should see
a lot of
at some point some of these players show up.
Okay, I see a container.
Oh, the Zork player 1, 2, 3.
Okay.
There we go. So if we go back, and I do a refresh here, and there they are.
Nice.
And what we're going to see in a second is they're going to see them start to play.
Okay, so we've got 3 of them.
Yep.
We should be able to.
And it's going to show in order
all of Azure.
How good they are.
Could we have?
There we go.
Oh, are they working?
They're playing, and look, open mailbox, and reveals a leaflet, and you see them starting to play moves and turns, and the score they're going to get right now. They're all.
Right, and this is on your credit card.
There's this, yeah. Well, and let's go a step further because we got these standby.
Let's go a step further.
Because that's okay, but that's only 3 more than what you showed.
Right.
Let's launch another 100.
Yeah. Fantastic use of.
Azure.
Time.
And if we go back here and do a refresh,
okay.
In a few seconds we will see lots of these players show up. What did I do? Refresh. And what's happening here is each one of these has got an Event Hub's connection pumping this into that UX. And there you can see a bunch of players spinning up. Let's go back to the dashboard, do a refresh, and there we go. And now we've got 100.
Zork at scale.
Zork at scale, yeah.
Very nice.
This is scale out Zork.
Fantastic. And one of them's going to win at some point, which is cool. Now, one of the things that's worth noting, though, is that we're playing around with Zork here, but Zork has been out in the world in various forms for many, many years. But you couldn't go and like teach a class on it because Zork isn't open source. But there is source out there. There's our friends like Jason Scott and the folks from the Internet Archive that you can find Zork online. There's different open source implementations of Zork. We thought if we were going to be using Zork in this way, that it would be cool to just go and open source Zork live at Ignite. So we're open sourcing Zork 1, 2, and 3 in association with our friends at Xbox, Activision, and Infocom, so shout out to them. And we're doing that by sending a pull request to our friends at Historical Source, and you can go and play with that now.
Yeah.
And you can go and maybe teach a class on Zork and do silly stuff like that.
And then we'll also post the links to these GitHub repos for the Docker container and for the Swarm thing if you want to go play that.
So go and explore, learn about that. There's a lot of really great .NET implementations of Zork. There's Python implementations of Zork. Okay, cool. So now you have spun up 100 Zorks, and I don't know how I'm going to make that much cooler.
I don't think you can.
Okay, but I do feel like we need to connect the dots here because you've got all this computing power. You might as well go and abuse it in some way. I was playing Zork on the Altair. Now you're playing Zork in a container. How are we going to get Altair into the
how are we going to
connect
this
the dots
thing
here?
To the cloud?
Yes. So do that. You have 14 minutes.
Well, okay. What I want to show you is I've got a program here that is designed to take a bitmap and burn CPU cores.
It's taking a bitmap or like a GIF or whatever, and you're going to take the pixels of that, and you're going to burn. Okay,
now I don't know which browser tab you've got for this one again.
I understand that it's always my fault.
Well, look at this.
I know exactly where everything is. Have you seen my desktop?
No.
No. Okay.
All right, which? Oh, wait, I know what we're doing. It's my fault.
It is your fault, yeah. I didn't want to say anything.
Yeah. And this is running at a front end for that tool that will show us how cores are being burned.
Right.
On this
you know
machine.
how Task Manager has like, I have like 12 CPUs on
so
mine?
He has
more than 12.
This is a Linux machine in the cloud, and it's got this number of cores on it.
1,792.
Yeah.
You couldn't get the last 8?
No.
Okay.
Too expensive.
Okay.
So to put that into context,
so that's your Task Manager.
Yeah. This is Scott's Task Manager. He's only got, what is that?
Do you need to do a side-by-side measurement?
Yeah, side-by-side. Look at that. This is my Task Manager.
Okay.
So, and here, and this thing, this is a custom Task Manager, so I can do cool stuff like show GIFs of Scott. So if I go back to CPU. And by the way, here's the code, the Rust code.
That is 1,792 CPUs in the cloud used to troll me.
Yeah.
Russinovich!
Yeah, it cost a lot of money, but it was worth it.
Was it worth it?
Yeah.
I think it probably was worth it. That's kind of awesome.
So let me go back and stop this.
The fact that it's a GIF is killing me, man.
But to connect this with that, what I've done is create
that part,
an Altair emulator on top of it. So this is now taking, and just to show you, this is really just, here's the raw task manager, but here's like a custom view of that that highlights things, and you can actually interact with this emulated, turn on the lights, flip the lights like Scott was doing.
You've got these 1,700, almost 1,800 pixels, all simulating an Altair.
Yeah.
But my Altair is here, and I can touch it.
This one's better though.
But that one doesn't do anything. It just says computer. We need to connect the two, and we only have 12.
And then we could load programs on it too.
We could load programs. We could run stuff like this. Because this would be a good use of everyone's time and resources. Okay. So let's go back to the slides.
Yeah.
Do we know how we could emulate this? Let me see if I can find how we could use the world's computer in this way. That's not Azure. That's an older Azure. I remember
that's the Silverlight Azure.
That was it.
No,
that's the new Azure. Look at this.
Yeah. You didn't show the Silverlight Azure.
I'm trying to think about if any of these, I could use any of these things from the marketplace to solve this problem for me. We get Zork in the cloud. There you go. That's the architecture that I'm planning. It's Rube,
to connect the two.
Rube Goldbergian is what we're going to do. Okay, here's our goal. Here's what we're going to do. We're going to connect all the dots. So, how could I do this in the stupidest way possible? Okay, let's go and open up.
The first thing you need to do is get output from that thing.
I need output from this thing, and I need to talk to this thing. I could connect some wires to it, but I've got a camera. Therefore, machine learning. Okay?
It's not AI?
It's machine learning.
Not AI?
No, not AI. I'm going to go and I'm going to click on each of these LEDs and track them with the camera using Python and a library to determine brightness of each of these, because this is also a good use of the crowd's time. Okay, and then we're going to go and start this up, and I'm going to figure out how. Let me think about this. I need to get. Let's do emoji. That'd be good. Okay. So that is too bright. I need to get back to Pong, which is bit mask. Scheiße.
Reboot.
I'm trying to remember. Oh, start, reset.
Oh, hey.
Hey!
Hey.
Okay, cool. So now I have detected the LEDs with the webcam, and I'm making a stream of data. Excellent. Okay? This is so useful for business. So now I'm creating 28 frames a second bit mask of these icons. Now I need to UDP. I'm going to take a UDP bridge, and then I'm going to go and broadcast all of that locally. But UDP is only on my computer, which is not helpful. So then I need to use a tool like ngrok to open up a port, and I'm going to port forward this
to the my server.
Well, to the internet. First, I need to make a WebSocket bridge. So now I have a WebSocket bridge written in JavaScript that is showing me those, and then to prove that that's real, I put my hand over that. That is, in fact, real. Okay. And I may or may not have bumped this.
You did bump it, yeah.
Yeah, thank you for that. There we go.
You're not quite aligned, but
it's good enough for government work. Okay. So now I'm going to take that URL into Notepad, and I'm going to change it from HTTP to WebSockets, web secure sockets. And then I'm going to go over to your abomination. Where is your abomination anyway, dude?
So, yeah.
Remember when we were talking, remember when you were complaining that I don't know where anything is?
Task manager.
Is this it?
Yeah.
I'm going to put it in here because that couldn't be smaller.
Yeah.
So
well,
good UX there.
My AI agent.
Now I'm going to connect to it. And now,
look at that.
All right, hang on. Let's prove that it works, though.
It works?
It's so dumb. it's so stupid.
So we've got this Altair going to a camera with an ML algorithm
running on the NPU on the Surface machine.
NPU.
Then
sending it to a bridge.
Broadcasting at UDP to the local network. Then I realized when it was too late that that was not going to get me out onto the internet.
Yeah. So then
I packed the bytes up and I threw them with WebSockets out to ngrok.
Yeah. Which then my server is now picking up.
So then you're connecting to my public node, which looks like this is you, that's me.
Yeah.
This is the mask that you're picking up. Then you're pulling that out, running it into your Altair emulator. So this is the least efficient way to do anything. And then we're sending it from this Altair running an Intel 8080. It would have been, now I'm thinking we should have had 8080 freaking CPUs, bro. We have 1792. This whole thing is unshippable.
Do you want to start over?
We got to start over. 8080 CPUs. One of the things that is worth noting and hitting that is important that Mark said a little bit at the beginning is that every piece of code here, everything that we did was vibed.
Yeah.
That's not to say that we think you should vibe. It just means that vibe coding has, for us, been a delight.
It's brought back a lot of joy to programming. Because you know what, I think you phrased it, there's been a lot of ideas like I wish I could do this or I want to do that, and then you think if I sat down and actually coded it, that would take me a week.
Yeah.
And I just don't have the time to go dedicate to this frivolous thing.
That much
time. Now, yeah, this. And this is like, now we can do frivolous things like this. AI. That's awesome.
No, but I learned a lot. Like I was playing with Zork. I built the Zork swarm. I built the Zork Docker container. I learned a bunch about Python. You were doing a bunch of stuff in Rust. You got to put the GIFs up into the Godzilla machine here, which is still costing.
It's like I look for any excuse to get access to that machine. And if I feel like I'm going to do a demo at Ignite, they're like, here's the machine, and then I get to play with it. And
now, when we say it's vibes, though, people might say, well, if you're going to go and vibe that whole thing, then you probably just did it in one shot. Do you think anyone could do that? Like, what's your take on vibe coding versus experience?
Well, you and I have a lot to talk about this. I think the reason we're able to vibe stuff like this is that we already understand the architecture, we understand the frameworks, we understand the tools. We might not be an expert at writing a language, but we're an expert at reading the language. Because it's like human language.
Yeah.
You can understand languages generally a lot more easily than emit the language, speak the language, or write the language. And the same thing applies to programming. But I think that the challenge we see is that if you don't get the fundamentals, if you don't learn the hard way, like a lot of us in this room, most of us in this room have done, you're just not going to be able to get the productivity boost from vibing. What did you do?
I've ruined it. Now it's over.
So the fundamentals still matter in the world of vibe coding.
They very much do. And understanding distributed systems, understanding the fundamentals matters a lot. Now, in the past, you were the CPU. You understood what was going on in the Altair. You could understand the entire stack. And even though we were joking about you understanding the entire stack, no one understands the full stack of Azure. Azure is a community. Yeah. There's a community
hundreds of services,
fellows, hundreds of services. We have a general sense of how it works, but that entire thing now has become a description of a desired behavior.
Yeah.
When we deployed these things, we deployed them with bicep, with declarative techniques. The Docker container was a declarative technique. So we went through the Altair personal computer, the cloud, and then into AI. It was kind of a collaboration. Arguably, we were talking to ourselves in the mirror.
Yeah.
Right? Like it didn't do anything that we didn't know that we could do ourselves. But
with enough time and effort, right?
With enough time and effort. How much time do you think we put into this thing?
A few days, 4 or 5 days.
4 or 5 days?
Yeah.
Really?
Yeah.
Like it was not a lot. And I don't mean 4 or 5 days of 8 hours.
Yeah, it's 4 or 5 days of in the background, an hour here, an hour there.
Yeah, 4 or 5 lunch hours here and there. The Altair thing was fun. It took longer to open source Zork.
Yeah.
Because that involved humans doing work. But the most important thing, if we could say one thing to close out and to give you something to think about, is when you connect all of these dots, whether it be from CPU, commanding, describing, collaborating with the systems, you've got to have agentic. You got to believe it.
This is like the under construction thing.
I just thought that was the classiest way to say. We had to say agentic at some point in the talk. Otherwise, they wouldn't let us do the talk at all.
Yeah. They actually use AI to go read your slides, and they're like,
they do.
Do you have agentic?
They were looking for the word agentic. So all of this stuff is going to be online. It's going to be on GitHub. We've got Zork, which is over at Historical Source. You can go and play with that.
Yeah.
I've got the Zork Swarm Solver up on my blog as well.
And the custom Linux task manager. So if you get your super mega Godzilla beast, have fun.
When you get access to that machine, you can do that.
Yeah.
All of this stuff, we wanted to make it completely transparent because this has just been a celebration of plugging in Lego pieces over the last 50 years from Altair to Azure, from a machine that we can fully understand to a machine that we then collaborate with. I had a lot of fun, and I appreciate you.
I had a lot of fun, too.
Coming along with us.
Now, did you learn something?
Nope. But did you have fun?
Yeah.
And that's all that matters.
Yeah.
Thank you very much for spending time with us today.